Okay, recording has started. So, welcome to today's tutorial. We'll be going through the past paper. So, we're going to finish where we left off. Remember, we said we're going to do question 5, 6, 7, and 8, if I'm not mistaken. So, those are the questions that were left in the question paper. So, we're going to cover those now. So, let me close this. Yeah, first years are going through the most. Dr. Stung is making things hard now. I rather be strong because they have me as their tut. So I'm gonna open. Okay, I don't think I'm gonna use Notepad. Yeah, I doubt I'm gonna use Notepad. So I'm gonna open Microsoft Word as usual because I need to generate a PDF. So I'm gonna start it as a Word document. So question 5, right? So question 5, let's see what question 5 wants. So discuss the changes required to the main class below in order for it to become a JavaFX application. You can assume all relevant packages have been imported. So they say assume all the packages have been imported. So that means you don't have to write import statements, right? You don't have to say import JavaFX dot what. You don't have to import. That's basically what they mean there. So now what I'm going to do is I'm gonna go here and only answer what I'm required to write, right? They said discuss the changes that need to be made. So what changes do I need to make with on top of the already existing code, right? So the already existing code that I have is that I have a main function which is part of the main class, right? So this is just an empty main class. Sorry, I don't know why people just be randomly calling. Let me put my phone in airplane mode. Yeah, so sorry about that. So let's continue. So discuss the changes required to the main class in order for it to become a JavaFX application. So in order for it to become a JavaFX application, right, the very first thing you need to do is make that class extend the application class so that it counts as a JavaFX application. So they said, what changes should I make? Changes that you should make, you're gonna say um, make main class extend application class, right? That's the very first thing you can do because they didn't talk about code, right? The thing that if you look at the question, right, they didn't necessarily talk about the code and stuff, right? So you don't have to necessarily write code, but seems like they want a bit of code here because they meant if they didn't want code to a certain extent, they wouldn't have mentioned this part about you don't have to assume all the relevant packages are imported. Um, Technically, but they could also mean, I think that statement could also mean that, let me see. Yeah, could also mean that don't tell us that what's missing is imports. That's what they could also be avoiding. That's why they told you this. Because you could say the changes that need to be made is that you need to tell Java that you need to import this from the JavaFX package. So yeah, you don't have to do that. So I'm just gonna write. The question didn't state code. They just said what changes need to be made. Step one, that class should extend the application class. In this case, the class is called the main class. Hence, I said make the main class extend application class. And then number two is to override a start method which takes in a parameter of type stage, right? And and this function throws an exception. If you check in your in when you're doing Java FX, right? That start method, you do override it and it takes in a stage, but it also throws an exception. That's something you need to remember. It also throws an exception. So that's something that's very important to keep in mind. Number one, it extends application class to make this a Java application, right? When you extend application class, you're also forced to override the start method. So you need to also mention that you need to override a start method and you specify that it takes in a parameter of type stage and it also throws an exception. I think that's where you get the full marks. I think maybe this part could be worth 2 marks and then this one could be worth 3 marks. I think that's how it is. So what I'm going to do is we are done with this one. So we're going to go to question B. So question B, it says name any two helper classes in Java FX. So by helper classes, it's like a class that is used to help Java facilitate its things, right? For Java to be Java FX to be able to, I think, to be able to run in a way. So they said any two, right? It means that there's more than two. Me, the classes that I'm thinking of here, the helper, and the keyword here is helper, right? To help us work with JavaFX. The classes that I can think of, the classes themselves is two. It's a stage and a scene. Those are the classes that I'm thinking of right now. You could mention other ones, but the ones that I'm thinking of right now, it's stage and scene class. Because remember the stage, it allows us to remember we need to have a scene on a stage. And so that means we need a type, something of type stage and something of type scene. So stage and scene class. They help us to, because if you remember with the stage, you use the stage and then the last statement inside that method, you say primary stage dot show, right? To help you show the stage, right? So I can say those are helper classes, right? And then number three, C, I mean, we need to list any three layout managers, right? Any three. A layout manager, right? You can, as the word suggests, it's a it manages it's a manager for a specific layout. By layout, it means the structure of the components, right? Of the nodes. Where are you placing the buttons? Is it in sequential order, like on top of another, or it's below, or it's vertical, or it's horizontal? There's a lot of layout managers. There's a lot. So I'm gonna list them. So you can have border pane, you can have stack pane, you can have VBox, you can have HBox, you can have grid pane. Yeah, there's this they said any three. You don't have to list all of them. They said three. I'll just list all of these so that in the future, if you wanna have unique answers. So yeah, that's basically what you're supposed to write in question 5. And then question 6. Exception. We did talk about this, and I don't know whether we're covering semester test one. I think this was semester test one. Yeah, if I'm not mistaken. So question 6, we did talk about checked and unchecked exceptions, if you still remember. Those are the two different types of exceptions. So they say discuss. So it means you need to list the exception and give a short description of it. So let's discuss them. So A would be the question about exceptions, right? So we have let's start with checked. So we have checked exceptions right? So you can say these are the exceptions that the compiler forces you or enforces. You couldn't say enforces you. Yeah, I think the proper terminology for it is enforce. It enforces you to check them, right? These are the exceptions that the compiler enforces you to check, right? Enforces you to check. And there's exceptions occur at compile time. That's something you need to understand. These exceptions, they happen or they occur at compile time. Then we have unchecked exceptions, right? As the name suggests, they're unchecked, right? Meaning you don't check them. So basically, there's no, it's not, it's less strict, right? So there's exceptions that the compiler does not enforce you to check. And then you need to also specify that there's exceptions occur at runtime. And also the descendants, right, of the runtime exception class. Basically, all anything that's that if you want to find out what is an unchecked exception, you need to ask yourself this question: does it inherit from the runtime exception base class? That's basically what I'm saying here. That the unchecked exception, these are the exceptions that the compiler does not enforce you to check, right? Does not enforce the programmer. Remember, you are a programmer, right? So you can type, you don't have to, you don't say you say the program. The compiler enforces the programmer. So let me also type programmer here. So with unchecked exceptions, these are the exceptions that you are not forced to check, right? They're optional. So these exceptions are the exceptions that the compiler does not enforce the programmer to check. These exceptions occur at runtime, and they are also descendants of the runtime exception class. And they are descendants of the runtime exception class. And then this is the proper definition that you have to use for that. And then B, yeah. So B, when can assertions be used to replace exceptions? This is a very easy answer here. So basically, they're asking you why would you favor assertions over exceptions? Like why would you prefer assertions? In what case, in what situation would that be applicable or allowed? It's when, remember the difference between an exception and an assertion, right? I didn't think I would have to use Notepad, but let me just use it. So an assertion, right? Assertion, it basically tests the correctness of the code. That's the main thing of assertion. It tests how correct your solution is. On the other hand, exceptions, right? Is basically something unexpected has occurred in the program, right? Or in the code, right? Yeah, it's up to you. You can say the correctness of the code or of the program. You can phrase it, you can use code or program, but I'm gonna you choose the keyword program. I think that's a better term for it. So assertions is just to test the correctness of the program. So basically, you're testing, is it true that this is the case? Hence, assertions, they work with Boolean, right? True or false. And then, and I think the thing is, I forgot. I'm always testing out different programming languages. I think assertions in Java, you say assert, right? Space, then a condition here. That will return true or false, whatever that condition is. For example, assert num, for example, num is equals to 0. Something like this. I forgot. And then you can also put a message, or I think like this, and then you can put a message or something like that. Yeah, I forgot the how to actually type an assertion, but you don't need to know the code part. They just ask theory. So assertions that they test the correctness of the program. So the simple way to answer this is to just describe what are assertions. Because when you describe what an assertion is, you're actually answering why you choose an assertion. Because here the answer is that assertions they check correctness of the program, of which that's when you'd want to use assertions when you are checking the correctness of a program. So as you can see, you defining the thing itself, you end up indirectly answering the question. So I'm gonna say when the programmer wants to test the correctness of the program, that's when you'd use assertions. Of which, if you read this, you'll see that this is basically the definition of an assertion. But that's all you have to write. There's as you can see, it's all worth 1 mark. So you don't have to write a lot. And just know that okay, BC, right? Just know that the mark allocation is equivalent to the number of minutes you're supposed to spend on the question. If it's 1 mark, they're saying it's maximum 1 minute you must spend to answer this question. If it's 4 marks, it's maximum 4 minutes. So that's how it works. Then if you add up the minutes, sometimes it might be smaller than this actual number. Those extra minutes is for other students who are very slow with writing. Some students they write slow, so they're trying to help everyone to pass at least. They want to accommodate everyone. So we've answered this. That's done. And then with regards to multi-threading in Java, discuss the similarities and differences between a thread yields compared to when a thread slips. So similarities and differences, right? The way I would describe this, right, or the way I would answer this is you explain what yielding is, and you explain what is sleeping, or like when a thread sleeps. Because when you explain those, you actually expose both their similarities and their differences. Um, so yeah, before we continue, I don't think it's necessary, but I think I should, but I don't see it being necessary, but I think I should. So let me open Chrome. I'm gonna explain this whole thread thing. So draw.io. So a thread, right? Remember, we have what we call tasks. So when you basically when the program loads, right, onto the RAM, onto random access memory. When that program loads, the random access memory, right? Remember, I think it's part of the CPU. So you're also using the central processing unit, which is the CPU. So that program is going to have certain things that it does, right? And those things that the program does, we call those things tasks, right? So those tasks can be anything, whatever that application does, whatever that program of yours, whatever it does, you're gonna have some tasks, right? Things that it does. So I'm gonna represent that through it's fine. I can just write text. So let's say it does something, right? So I'm gonna say do something. I'm basically gonna mimic the slides, right? So do something, and then it is do something else, and then we have do something different. Do something different. Let me choose different colors for it, right? So we have this, and that. So you might ask, what am I trying to explain here? You'll see it in just a minute. So you can imagine do something else, do something different. All of these are different tasks, right? They're all different tasks, hence the different colors. There's times whereby we want to do one task after the other. So let me show you the flow of that. Let me show you an example of that application. So that application would start here, right? It will start here. There's our start. And then I can say this is our end over here. Remember, I'm trying to mimic the slides. So this will be the start over here. And then I'm going to use a different color. So let me use that green there. And then I need to select this. And then purple. I think the purple should work. Okay, admit. So let me just double check. Okay, at least people are muted this time around. So minimize. So sometimes most programs, right? If you notice Java, right, most of the time, the code that we write, I get it starts it from top to bottom. So it does one thing after another, like right step by step. So it's they say your program starts here. Or just think of the start as like you clicking the run button inside Eclipse. Then your code does something. After it does something, it does something else. After it does something, it does something else again. And then eventually it reaches an end whereby the application is done running. So this is what we would call sequential, right? So this will be sequential. So this will be sequential, right? Meaning one after another, like a queue. You can think of it as like a queue. It's just one after another in sequential order. But then there's sometimes, right, whereby you want to perform tasks independent, right? Meaning this can run independently on its own. This runs on its own. This runs on its own. So when you run all these tasks independently, when you have a situation like that, when you want to run them independently, that's when things like multi-threading comes in place. Why is it called multi-threading? If you look at the word multi-threading, it's basically a combination of two words, multi plus threading. The word threading comes from the word thread. So as you can see, it's multi-thread, right? Because you use multiple. Multi stands for multiple, and then thread just thread. So multiple threads are being used, right? Because remember, if you want to run the tasks independently at the same time, simultaneously, basically, this is running. While that is running, this one is also running. While this one is also running, and this one is running, also the third one is running. So they are all running at the same time. You can think of it as like this is a race, right? This is the person number one, this is person number two, this is person number three, right? You can view it in that way if it helps. So this will be person number, you can think of it as like whether it's Olympics or whatever. So this is the first person, second person, third person. The way I was explaining it to be, which is sequential, it would mean that if it was a race, you'd say I know that's weird. It's very weird what I'm about to say. But if you're doing it sequentially, this means that you let one person from one country run until he reaches the finish line. Then you wait for the next person. I get it sequential. Then person number two runs until he reaches the finish line. And then person number three runs until he gets to the finish line. So it's sequential, one after the other. So you wait for the first one to finish before you run the other task. And you can think of these people as tasks, right? Then what about the multi-threading? Multi-threading, we use multi-threading when we want to run things concurrently. By concurrently, right, it's a fancy name for saying simultaneously. If you remember simultaneous equations in high school, right? I agree, simultaneous, that means while you're finding X, you're also finding Y. You are multitasking. Another word for it to be multitask. That's basically how computers manage to do multitasking. And in order for a computer to be able to do multitasking, if you check the slides, you must have more processor or processing cores than threads, right? Cores must be greater than the number of threads. Yeah, because the CPU uses the processing cores to run the threads, right? So yeah, that's something you need to understand. And if you are you're interested in understanding or knowing how many cores your laptop has, I can also tell you that a free tip. You can click on your keyboard, press the Windows R for Windows key button or the Windows symbol on your keyboard, followed by the letter R. Then there's gonna be a pop-up like this, right? Then you type in ms config, right? For Microsoft configuration, but just type it as ms config, small letters, and then you press OK. Then it's gonna do a pop-up. Then you click on boot, right? You want to go to boot. Then you click on advanced options. I would advise you do this because to be honest, if you don't do this, your laptop is actually to be honest, your laptop is actually working at its lowest possible power because by default it uses the smallest number of processors. So you want to yours won't be you'll be unchecked, so it'll be like this. So you see that it's gray. I cannot click. Then you select this box. Then you click here. You see by default it'll be on 1. Then you scroll down to the highest number, which is 8. Mine is maximum 8 cores. So if you notice your laptops, right, the more the cores you have, the faster the laptop most of the time. Like 99% of the time, it's like that. Some laptops have 24 cores. Like those are like last number laptops. Like those are like the best of the best laptops, like gaming laptops. They have like 24 processors. Some 32. So yeah, there's powerful laptops out there. So mine is 8. Yours most probably is gonna be 4 or 6. Yours. Some might even be higher than mine, but most of your laptops would be 4 or 6 cores, right? So you choose the maximum number, and you click OK, then you click apply, then you click OK. It's gonna tell you you wanna restart whatever, then you restart your laptop, then it's gonna save the changes. So yeah, you can experiment with the operating system if you want to find how to find number of threads or number of cores, all of that. You can do that on your own time. So we understand concurrent sequential. I'm trying to explain concurrent. Concurrent, I want it to be to run simultaneous. What do I mean by that? So it means all of this they move simultaneously at the same time, independently. That's the whole point. That's the whole notion behind multi-threading. There's nothing fancy about multi-threading. That's the only thing we're trying to achieve multitasking. That's all. So I hope this explanation makes it clear. So you see that all these sprinters, whatever, these people that run, they are running at the same time, independently, concurrently, right? Another word for concurrently is simultaneously. So that's what I wanted to explain. So that means my diagram needs to be updated. So that means it can go from start and then it goes straight. Remember that running independently, so it goes here and then it goes here. And then this one goes from here up to here and then here up to here, right? But remember they're running independently, right? And then I can have another arrow from here. Okay, let me just make it start from here to here, right? And then to here. So you see they can run independently. So you can start here and then it goes and then it does something and then it reaches the end. While this one is also running on its own and then it also reaches the end. The whole point behind it. And another thing you need to understand is that in order to make in order, I'm gonna phrase it in English, in order to make a class runnable as a thread, it must implement the runnable interface. So in order for the class to be runnable, for you by runnable, remember English, right? We did talk about this. Runnable is combined with the two words run and able. So that means you are making the class to be able to be for you to be able to run it, right? To be able to run it as a thread. But I don't like how they phrase it on the slides. They phrase it as a thread. You don't run it. Yeah, technically you run it as a thread, technically, right? But the correct way is to say that you run it inside of a thread. Because when you implement runnable interface, right, you make that class a task, not a thread, of which, remember, you start with a task, then you pass the task into a thread, because a thread, its main goal, right, is to run a task. That's all it does. That's all a thread does. It runs tasks. So therefore, for you to phrase it as you're making the class to be runnable, for you to be able to run it as, that's wrong. The proper way to phrase it is you are making that class to be able to be run inside a thread, not as a thread, but inside of a thread. That was quite a lot of explanations. I hope that makes sense. So that's basically all we're talking about. The task can be anything, to be honest. For example, let me talk about let's talk about something simple. Let's talk about Microsoft Word, right? I can install numbers. I can, while I'm doing that, I can make it bold. While I'm doing that, I can do something on, I can add a header, a footer, all those things, right? I can add a title, I can add spacing, all these things. You see that I'm multitasking. So Microsoft Word definitely uses multiple threads. So each thread that runs a specific task. So for example, there's a speaker or a micro whatever thingy for you to it connects to your speaker, right? Your laptop speaker. There's a thread running only the speaker button. Then there's a thread running only this. Then there's a thread for this, a thread for that, a thread for each and every single task. So that's the whole notion of multi-threading, so that an application is able to multitask. So for example, while I'm typing here, I can also just go here and say, I want to insert. You see, I'm doing something totally a different task. So that's multitasking. Then I can click pictures, insert, go. You see, it does another pop-up, which is another task. So multitasking, so multi-threading. So I hope that makes sense. So yeah, they want you to explain the difference between yielding and sleeping. They're basically the same thing. That's why they said discuss the similarities and differences. If you look at the definition of yielding and sleeping, it's exactly the same thing. The difference is that with sleeping, you specify the minimum time. With yielding, you don't specify any time. You just yield. So thread yielding. What is yielding? What is sleeping? Thread yielding, this is when you thread yielding, this is the process when you I don't know how I'm gonna phrase it. Let me say the process of releasing the CPU, right, in order for other in releasing CPU in order for other, you can say tasks or threads. Not sure which right terminology to use. In order for other, I think you can use threads to define it. So basically, you release yielding is basically freeing the CPU so that you can run other threads. That's all. You free it. By freeing, right? If you think about freeing, let me try to explain freeing. What do I mean by releasing the CPU? CPU releasing and freeing, it's like you can view it as like this, right? Remember, these are different tasks, right? When you say yield, right, you basically release the CPU so that other threads or other tasks can be run. What does that mean? So let's say you this is the task, right? And then the tasks run, and then you yield to release the CPU. So basically, you free up space here so that another task can be added here and run. Right? It's like this person has been removed, right? Disappears, and then you introduce another person here. So that's the whole process of yielding. You can put it in your own words in whatever way you can. So in order for I'm gonna say other tasks to be executed, right? So so you release the CPU in order for other tasks to be executed. Another word for executed, you can say run, right? Executed or run. And then thread sleeping, right? Is the same thing, but then the difference is that you specify the minimum time. And then in order for other tasks to be executed, the process of releasing the CPU in order for other tasks to be executed or run. And then you specify that unlike yielding, sleeping specifies the minimum time, the minimum time, the minimum time for the thread to sleep, or you can say the minimum time for the thread to sleep, right? They specify what minimum time before rescheduling. Rescheduling. If you check all of this definition, I'm using the terminologies on the slides. So I would advise you use the same terminology. So thread sleeping is exactly the same as yielding. The only difference is that you specify the minimum time you should sleep, right? Or you should yield. Though in this case, it's sleeping, so I'm gonna use the term sleep. But when you're explaining yielding, you can use the term yield. But in this case, I'm gonna say you specify the minimum time the thread sleeps, right? In order for other tasks to be run. So that's basically that. I hope that makes sense. There's quite a lot of explanation there. Then we have okay, we're done question 6. Then we go to design patterns, right? Question 7. Yeah, design patterns are really annoying, Shem. You're gonna have to study all the patterns they can. You see how they're asking it. There's a design pattern question here. You scroll down, there's another design pattern question here. So you need to know all of them. You don't have a choice. So let's look at this design pattern question, right? The Datadyne Inc. is a large company that has a system to manage its data warehouse, right? So we're managing the data warehouse. They would like to make sure, or they would like to make some form of upgrade, right? To the system that would enable them to streamline the way in which they perform operations. So the thing that gave it away for me, it was the keyword operation and log, right? You log which operations are being done and the ones that have been performed, right? The company has outlined the following as candidates for a design pattern to apply. So basically, the company has chosen these 3 design patterns, and like as the ones that they could use, you must choose the one that's the most optimal. Basically, the one that's like the most correct one, the most efficient one. In this case, I would say it's the command design pattern. The other ones are they're not applicable in this scenario. These 2 they're not applicable because I saw logging is involved and operations, right? So they want a streamline in which they perform operations as well as a means to log which operations are being done. So how do you answer it? So let's start with A. So with A, you choose which design pattern. That's all you have to type. They said which. They didn't say, you don't specify, you don't explain anything here. Just specify which one. So command design pattern. That's it. Done. Then you go to the next question. The next question says, discuss the reasons for why you've chosen the design pattern. Like I said, logging. So one of them is logging. So I'm gonna say, come on. So the way you'd support the logging, right? How do I put it? The way you'd answer this question, like which one, why did you choose the design pattern? You'd have to actually kind of you see when you go to the slides, you see that part that says for each design pattern, the part that says when it should be used, this design pattern, and then it lists the reasons why when it should be used. Those are the reasons you should be typing here. Those are the reasons they're looking for. In this case, some of them they happen to be kind of hinted in the paragraph in this paragraph. So I'm gonna use some of them. So support logging of actions, right, as commands. So you need the application needs to be able to support logging of actions as commands. And then another thing that gave it away, they said a form of upgrade to the system that would enable them to streamline the way in which they perform operations, right? So as a means to log, blah blah blah. Me, the one that I can, it's you can put. Remember, you can put any of the reasons here. There's a lot. If you check the slides under when this design pattern should be used, there's a lot of reasons under that. So the one that I'll use is that with this design pattern, right? You make what's that word? I forgot the right word. What? Yeah, yeah, you parameterize. Yeah, I think they use the word parameterize the commands as objects, right? So basically, each command you you make it its own class. That's basically the command design pattern. Each command you make it a class. So for example, by command, right? Uh, let's say your application. Let me explain what I mean by command. Let's say application involves something basic, involves running, it involves swimming, it involves fishing, right? These are commands, right? Run, actions, right? You can view them as actions. So action, these are all actions, right? It's something you're doing, which is a verb, right? Actions. So you're running, swimming, and fishing. So the command design pattern, the way it works is that every single command you make it its own object. So you say class running, and then you say class swimming. That's what I mean by what I just finished typing. Then you say class fishing. So all of the commands or actions, right? This can be viewed as commands or actions. You convert them into objects, and you convert them into what I call concrete objects, right? Into concrete objects. So just keep that in mind. So yeah, that's all the reasons you have to. These are the two reasons I chose. You can choose whatever reasons you want to use. And then with limitations, right? There's no limitations on the slides, so you have to go do your research on that, on each design pattern. You have to go find out what are the limitations of each design pattern on your own, right? I remember Mr. Magnalal, he told you, or Mr. Fao, they always tell you that you guys are old, right? You guys are grown-ups now, so you must go do your research for all the design patterns. Like I said, they can bring any. So for C, discuss the limitations that need to be considered before implementing the design pattern. I did send you the answer for this screenshot in the group. I sent you advantages and disadvantages because sometimes, right, you never know. Mr. Ofao might just come and be like, oh, this one's they're gonna cram question papers. Let me twist it around. He still brings the reasons one, right? And then for C, it says instead of limitation, it says advantages. You can do that. And then you crammed limitations and then it brings advantages. It's a very possible. It's an exam. Remember, this is an exam level. It's not semester test level. So what limitations are there? One of the limitations that you can see, right? If you can see for yourself, you see that every single action, as you can see, is converted into a concrete class. So that means if I have 16 actions, that means I'm going to have 16 classes. You see that it doesn't promote reusability. So basically, I have a lot of things involved, a lot of classes. So the two limitations you can list here, you can say that you end up having a lot of classes and objects, right? To achieve that specific goal, to achieve a specific goal, right? Or task, or whatever. You end up creating lots of classes and objects. That's a downfall to that. And another downfall or another limitation is that every single command is converted into a concrete command, a concrete class, right? Concrete command, but like a concrete class, right? Or yeah, you can say concrete class. Yeah, concrete class. But it did explain the screenshot that I sent you did explain. You can use the explanations from there. So yeah, these are the limitations. You're gonna have a lot of classes and objects that are involved. But I think that's by far the easiest one to remember. And then every single command is converted to its own specific class. You can phrase it in that way instead if this is too complicated. You can say every single command is converted into its own class. You can phrase it in that way. So let me write another way to phrase this. You can say every single command is converted into its own concrete class. That's the downfall. So it doesn't promote reusability. We can't have a base class. You see the problem. It's very bad design wise, right? Even maintenance, because remember the main thing about design pattern is to allow us to to have flexibility so that we can be able to maintain our system, right? Our program. So that when you install an update, we did talk about design patterns. When I install an update, I don't affect the users, right? I don't disturb them. They can still continue using the app while the updates are being added. Then we send a notification to the users or to the client that listen, there's a new update. Go to the Play Store, whether that's the Google Play Store or the App Store for iOS and macOS, right? Go there and install this update. And then when you install the update, it'll continue and use your previous information without starting afresh. Also, that's another benefit, right? Design patterns, they help us with a lot, especially with maintenance of software in the long run. So yeah, so that's all I have to explain on command design pattern. And then question 8, we have the proxy design pattern, and then we'll be done with this question paper. So the proxy, right? Let me think about it. Yeah, we have abstract and real. Yeah, I'm thinking about the design, right? The pattern. I remember it now. I was trying to remember it in my head. Okay, we don't need this. We need to do the UMO, right? So I'm gonna say this dear, right? Yeah, these design patterns they can confuse you sometimes. There's a lot of theory with ComSci 2A. That's the thing. It's a lot. Yeah, ComSci 2B is the theory is better. It's not a lot, but it's quite complex. That's the problem. And there's a lot of calculations too in ComSci 2B. Like you'll be calculating a lot of things there. Especially semester test too. If you don't study for ComSci 2B, last year students were getting like 38%, 32% semester test one. Like it's ComSci 2B is not a joke. 2A is still okay. It's still fine. It's doable. You can get even an award for ComSci 2A. 2B, it's a whole different story, that one. So if you think you're gonna behave the same way you behaved in first semester, you're gonna fail. And I want you to remember this recording when you're in second semester and you failed. That I did tell you, I did give you a warning. So the proxy design pattern, it's also called the surrogate design pattern. You see why that is. I'll explain why. It's also called the surrogate design pattern, right? So proxy or surrogate. But I'm gonna just use surrogate to make it very easy to understand. By surrogate, remember, let me see. I don't know. I just want to be accurate. I don't want to make a mistake. Surrogate meaning. I guess surrogate is someone who carries your baby, right? Yeah. So relating to childbirth by means of surrogacy, yeah. So that's okay. I just wanted to be sure. So we have what we call the abstract subject, right? Yeah, if I'm not mistaken, we have abstract subject. And then we have some operation, right? Just some operation. Keep it simple. Apply, and it's an interface, right? Remember, this is has to be an interface. So I'm gonna put a stereotype here and say it's an interface, right? So that it shows that this is an interface. And then I'm gonna have here. So here, that's when you have your client, right? You're gonna have the client, which is the main dot cp main dot java. I was teaching C++ today, so that's why I'm saying .cpp. But this is the client. You can have the client class, right? So this is the client. Then you're gonna have, remember this is an interface. You obviously need the concrete one. So we call the concrete one, it's gonna be an actual class. So we call that the real subject, right? And then it simply uses that, inherits that operation, right? I'm gonna make it void. Let's make it void. Right, I don't know why I forgot to put the type. Let's make it void to keep things simple, right? Because I just want you to see the template of the design pattern. Then comes the surrogate. Remember the whole point of a of a proxy design pattern, right? Is you create what you call a surrogate object, which is an object that represents the real object. So that means you don't actually have direct access to the real object. You only have access through the surrogate object. In a way, the surrogate object is like a representative of the real object. Hence, I like to use that example of a surrogate mother. Remember surrogate mother, right? Okay, let me finish putting the design pattern here. So we're gonna have this is the proxy subject, right? Or the surrogate. Another word for proxy is surrogate. Proxy or surrogate. And then obviously the surrogate is gonna need to keep track of the state of the original object. So I'm gonna call it original subject, which is of type real subject, right? And it's gonna be private because people don't need to know about the real object, right? That's why it's private. It shouldn't be known. They only know the surrogate, but the surrogate is actually representing the real object. That's the point that the proxy design pattern is trying to make. And then here you're going to have that operation again, right? Void. And then both of these classes, right? The real subject and the proxy subject, they both inherit from or they implement this interface, both of them. So I'm gonna use this, right? Realizes the interface. Both of them realize the interface. And then this also here, we realize that. And then we constraint, place a constraint or something. Let me, okay. That's not what I want. It's fine. Oh, can't I do this? Um, okay, I'm trying to experiment something. I can't, seems like it doesn't allow me. Okay, no, not that. Okay, let's do this first. So let's do because remember the real subject is contained or it's inside of the proxy subject class. So we did talk about that. That's basically composition or aggregation. Okay. Uh, okay, I need to align it. There we go. So there's the design pattern. And then the client uses this, right? That's the relationship there. It uses the abstract subject. And then here, right, the relationship between this and this, right, is that this one, the subject, represents this real subject. The proxy subject is a representative of real subject. If you check the design, the slides, it did actually put in the keyword represents. Yeah, so you see, I need to from here to here, right? And then I need to type in a message. So well, the message is that the proxy represents, right? And then click apply and then okay. And then, yeah, this is very bad, but it's fine. It's whatever. But as long as the point, you get the point. So the proxy subject, right? This one, it represents this one over here. So this proxy subject or the surrogate subject is a representative of real subject. So you might ask yourself, why am I passing the original subject here? You are passing the original subject here because remember how a surrogate works. Remember the surrogate, let's say this is the surrogate, it carries the child of this one. So that means the child of this one is contained inside of here, which basically means because remember, think about it like if you like use your brain, like think about it critically. You are your parents, right? You have your parents' DNA. So technically you are your parents. So that's why I just simply pass the real subject, even though I'm the proxy is trying to act as a surrogate, as like a surrogate mother, meaning a carrier of this one's child. But this one's child carries this one's DNA. So this one's child is basically that person, right? Like I said, you are your parents. So that's basically the whole concept here. I hope it makes it kind of makes sense. I hope you're having a light bulb moment because this just simply acts as a surrogate mother or yeah, surrogate mother, and then this is the actual mother, right? And then people will know this one, right? Because this is one who's pregnant, who's carrying the child. But that child that what this one is carrying is has DNA of this one, is this one's child. Or you might not say, yeah, you might say, some might argue and be like, well, it's not DNA. Yeah, technically it would be right, but it's this person's child. So you can just say it's that person, right? So that's why we are passing the state, the original object. That's why this one is contained inside of here because this one is carrying this one's child. So I hope that makes sense. So now let's translate this problem and apply this right to this problem, to this question. So I'm gonna scroll down a bit. Yeah. And then let's see what changes do we need to make. So the action, right? The operation in this case is printing. It's simply printing. You see, it's printing. So we have what we call a remote printer, right? So that means I'm gonna remember what I talked about design patterns. Try to apply the design pattern to the problem. Yeah, I know the UML says abstract subject. Don't call it abstract subject. Apply it to the problem. In this case, I have a remote printer, so I have some type of printer. So I'm gonna call the abstract the interface or abstract class. I'm gonna call it abstract printer, not abstract subject, because I'm applying it to the problem. Then under operations, I need to pass in the functions that are part of this problem, which is the print function. It's called print. So that means I need to rename it from operation to print. And the return type is no longer void, it's Boolean. It returns true or false. And then it takes in some document of type string, right? I think so. I think it's a document. Yeah, it takes in a document of type string. And then apply, and then okay. You see that the moment I change that, I have applied it to the question. It's, you see, abstract printer, not abstract subject. It's no longer vague. It's no longer just a template. It's an actual solution to a problem. I've applied it. Now is the function is no longer called operation, it's called print. So I need to change here and there. So the operation is now called print and it returns Boolean. Then new the value, the parameter is called document and it's of type string. Apply, okay. And then here, my bad, I forgot to rename the subject, the class. It's no longer called real subject. You need to call it the actual name, which is remote printer. So I'm gonna call it remote printer. So remote printer, then apply, and then okay. Then I also need to change the proxy. So it's no longer proxy subject. It's now, yeah, just call it proxy remote printer because it's a, why am I calling it like this? Remember the keyword proxy is like synonym for surrogate. So it's a surrogate for a remote printer. Basically, it's a carrier of remote printer's child, right? So hence proxy remote printer or surrogate remote printer. So I'm gonna call it proxy remote printer just for clarity. Like you can omit. The thing is, okay. The thing is, if you omit proxy, now it'll be like it'll show that you didn't apply it to the problem to the problem. So yeah, you'd have to have that proxy keyword somewhere. And then operation is print. It returns Boolean, and then document, and then string. Then apply, and then okay. And then I'm gonna stretch it a bit to the side. And then, yeah, that's fine. And then I'm gonna make this composition, right? Because the thing about it, it has to be composition. Because if this mother didn't exist, then there would be no need for the existence of the surrogate. So the surrogate is dependent on the existence of this mother, or else the surrogate wouldn't be a surrogate. So there's a life cycle dependence. It depends on the existence of the other one. So I'm gonna use composition instead of aggregation. So apply, which will be a black dot. I think on the slides there's also a black dot. Then I'm gonna go this side. Then I'm gonna go to here. You see, there's a class called client. Like enough, I did call it client already. You see, there it is there. And then it has a main function. So I need to add that main function. I shouldn't omit it. And remember the three dots, it means it's an array. If you understand Java, these three dots are specified in the textbook. If you read the textbook, it should be easy. I don't have time to explain that now. So client, we have operations, which is a function. We have one function, which is a main function. Static void, um, it's a void function. Yeah, it's a void function, right? Yeah. And then it takes in args. which is a type string array, right? You could put, the thing is, you can't put three dots in UML. You have to understand what three dots means. That's a Java convention. It's a Java way. You have to say string square bracket. So specify it's an array of strings. So apply, there we go. And then I'm gonna put it here. And then I'm going to, yeah, this, right? If you check, I think the UML, yeah, if you check this client is a relationship with this. I'm not sure about this and this, these two. I'm not sure if they should have, yeah, they should have a relationship. But then I want the message. Where's the message? Um, is it this one? No, it's not. Which one is the one with the message again? Okay, it's this one. So it should be here. Mm, no, I think it's in the other direction. I think it goes here, and then this one goes here, I think, if I'm not mistaken. And then it's like this. And then the message would be it uses, right? And then here, I'll move it downwards. Yeah. So the client uses this. And then this surrogate is a representative of remote printer. So it carries the seed for or the child, this one's child, right? Which in turn just simply means it's representing this mother, right? So this would be the full UML. So yeah, that's a lot to take in. So this would be the solution. Then I'm gonna save the image as scalable vector graphics, right? SVG. Save it on desktop. And then it's diagram one, and then save. Then go here. Question 8, right? Yeah, we already did question 9, so that's done. So this was the last question that I left to it. Then I'm gonna insert the image. Then I'll send the recording in the group. So there we go. At least it's very clear. That's what I like about SVG. Even when you zoom in, like if you really zoom in, you see that it doesn't become blurry at all. But then it's not, SVG is not meant for images with colors. It's just for UML. Only use SVG for UML. If your images have color, I would advise you to use PNG. So yeah, that's it for today's tutorial. I'll see you in tomorrow's tutorial when we start another past paper. Yeah, design patterns, yeah, I'll advise you guys to study them very well. Like there's quite a lot involved in these design patterns. So hope you guys have a lovely evening.